Hello, everybody. Thanks for still being here. So what I'm going to present today is called Mapping AI Use Cases to Large-Scale Analysis of Job Postings, which is joint work with Gad Lebanon, who's the chief economist at the Burning Glass Institute, and myself. So where did we start? Basically, what we were thinking about was to understand the effect of AI in the labor market, but more generally in anything, we want to first know what people actually use AI for. Like literally, like granularly, what do people use AI for? And so currently, there's not really a comprehensive source of what we'll call AI use cases. And in particular, on top of there not being a comprehensive sort of AI use cases, there isn't one which is like rapidly evolving as these AI use cases are evolving rapidly themselves. And so our thought was, okay, well, what about using job postings as a source of AI use cases? And so from the get-go, you can sort of think about, oh, there could be quite a bunch of advantages here, which is that they're high frequency. Like job postings arrive on a day-to-day basis. We literally have job postings from yesterday. And they're contemporaneous. Again, job postings from yesterday, right? And so the second useful thing about job posting as well is that they're automatically linked to a wealth of other information, such as firm names and industries, skills, educational requirements, and many more things. So the things you can think of as being in job postings. Now, the obvious disadvantage here is that they are buried inside of some large job posting text, and so you need to sort of get at them. And so, and the other one is that do firms actually post what they're going to do? Like, that's the other question. And so this is sort of what we set out to check is like, can we develop, first of all, a methodology to extract these AI use cases? And while doing that, is it the case that firms actually do post useful information on this? And so here, basically, this gives away the whole game. So after this, you can stop listening if you want. So first of all, we want it to be very general. So here, I'm putting the definition of what we are talking for, like AI ML. We're not talking Gen AI only. We're really broad. Basically, everything that sort of, it's the classic definition of AI, which is anything that learns on its own for its parameters, okay? And so the second thing we do is we develop a methodology. We develop a pipeline to process the 500 million job postings we have in the US, and it goes through identifying AI jobs, extracting a precise AI use case, and classifying into a taxonomy. And so this is the second contribution also, is the taxonomy itself. So by design, what we want is the AI use cases to be extremely granular, right? We want to really know what do people use it for, like exactly. But at the same time, this generates hundreds of thousands of AI use cases, which means that if you want to then zoom back out and do some analysis, you do need some structure on it. And so what we developed is a new taxonomy, which classifies these into a two-class system for now. So it has 19 classes and 79 subclasses. It's based on a domain function hierarchy, and I'll say a bit more what I mean by that. And very importantly, again, related to what I was saying before about we wanted to be dynamically responding to a fast, evolving situation, it's developed to be exactly that, dynamic. And so I'll tell you a bit more about what that means. And so finally, which is the bits we're only really starting to get into, obviously, there's tons of really cool stuff you can do with this data once you have it. And so here I will just give you a little bit of like some flavor of the cool things we can do with this new data. So let me start by going through the methodology. And here I will spend some time on the methodology, both because I think it's interesting to see what we did, but also because I think there are techniques which are worth knowing. Like we're all here to like learn about AI, but also maybe about how to use it. And so I'm going to talk a bit about that. So the pipeline essentially separates into 3 steps. You have finding the AI job postings, extracting the use cases, and classifying the use cases. So many challenges you can think of. You have scale. You have text data, which is a mess, which is complex. You have the task itself of extracting AI use cases is one of the more complex ones because you have it's like the AI use cases are dispersed and so on. You have the classification. It's a large and dynamic taxonomy. How do we do that? And finally, one which I do think is always worth mentioning is that we have finite resources, both in time and money, which means that you always have to figure out, like, within that constraint, how do we get this done? And so a quick overview. First step, finding these AI/ML job postings. So we classify into 3 classes: AI-related, AI-unrelated, but the firm itself says something about how it uses AI, for example, in the job description, and finally AI-unrelated. And then, for those of you who've done this, it's a pretty classic pipeline in terms of fine-tuning a model. We start off with keywords and skills to find an initial sample of AI of labels to train on. Then we have a labeling. So here, again, interesting, and this is going to be a theme across here. The labeling is done through GPT-4 Mini, and batch API, and finally, there's a classification step, which is which we train from the labels. So the one thing here, just for the nerds like me in the room, I want to mention something which is a useful tool for anybody who wants to do these type of things with again, the job postings are very large. They have often an average of 800 tokens at the very least. And so now since only basically January, there's been an easy model to do this classification with large context windows. So I think that's really useful for anybody who wants to do something like that. So that's why I wanted to mention it. Yes, so then the second step is extracting the AI use cases. So here, again, it's a complicated task. It would be really hard with classic NLP techniques. And so what we do for the extraction is we use O4 Mini and really work on fine-tuning the prompt so that it does more or less exactly, not never exactly, more or less exactly what you want it to do. And so that's how we extract the use cases. And so now I can finally stop talking about methodology and tell you a bit about the actual taxonomy. So first of all, again, just to remind ourselves, so the goal was to create a taxonomy of AI use cases, somewhat similarly in the spirit that we have ONET and Nike and so on. And so it's based on a domain function hierarchy. So you have, think of it like AI in customer service and experience, and then conversational systems and virtual assistants. And again, just to hammer this point down, we have dynamically responsive to appearance of new use cases in job postings. So again, the idea is that we're doing it backwards looking, so you can see how this looks. But going forward, we want something that's basically near contemporaneously tracking new things, new AI use cases as they appear. And so how do we do this? Well, essentially, we have, for every class and subclass, we have what we call an other category, which is sort of a catch-all category, which catches both vague use cases, but also use cases that don't fit into anything existing. And by putting it into its own other category, we can then very easily go into these and run clustering based on semantic similarity. And once you pass a certain threshold, you create a new subclass or a new class. And so this is the way we conceived the taxonomy, so that it's dynamic and can evolve as we go on. So the first iteration of this taxonomy was created basically through a comment. Originally, we wanted to be, idealistic when you start off of a project. We wanted it to be fully data-driven. It turns out that we're not there yet. Creating a taxonomy is a mess. And so it's basically this first iteration that we have now, which I'm going to show you in literally 10 seconds, is a combination of semantic clustering, of iterations through LLMs, of a lot of hand curation. So that was like a somewhat messy process. And so let me finally, I lied. 10 more seconds. Let me finally mention the actual classification, because here also that turned out to be surprisingly trickier than we thought. So you have, first of all, the classic problem of a fairly large number of classes and classifying into that. But more importantly, this other class, because it captures something broad rather than something specific, it tends to be hard to train. And so here, what ended up working pretty well is multitask learning, where essentially the classifier learns from the same transformer weights, but goes into 2 different classification heads with a combined loss. And that worked really well. Again, not sure that means that much to most people. I just want to mention some methodology can be useful for these type of tasks. So now we come to the actual results on the taxonomy. So first of all, 19 classes, 79 subclasses. I can obviously not show you all of those. So what I'm going to do is just give you a sort of a snapshot. These are the 19 classes. So again, as you can see, you have software and product development, transportation and mobility, entertainment, media and content creation, and so on. And I'm showing you across the time period, which, by the way, I should have mentioned, we're going from 2012 to now, basically. So this is the distribution across there. So once we have the classes, every class has a subclass, has about 3 to 4 subclasses. So you can see, for example, AI in defense and military systems has intelligence and security operations, defense technology and weapons systems, and military operations and decision systems. And I also wanted to give you, just rather than showing it to you by class, give you what are the top 10 subclasses. So maybe not very surprisingly, we have the like sort of core AI model algorithmic engineering subclass at the top, but then we sort of go across different classes, and we have, like, you can see market analytics and revenue growth, for instance, vehicle intelligence and safety systems. Okay. Sorry, that's the percentage of across the period, the percentage of these classes. So the percentage of posts that fall into this class. All right, and so now let me just give you a little bit of a taste of what the hopefully cool things we can do with this data is. So the first thing is, well, we want this to be a sort of a bellwether, right? We want to see what's happening with AI use cases. So what I'm showing you here is on the x-axis, the relative size in 2023 of each of the subclasses that are here. And then on the y-axis, I'm showing you the growth between 2023 and 2024. So you can think of this in quadrants, right? In some way, the most interesting quadrant is this one. So small in 2023, but with high growth, okay? And so you can see, in this graph, you see, like, on the very top, the development tools and productivity, personalized finance, financial service, and so on. And so you can already see the vague, like, 2023, right? ChatGPT hitting its stride, so this is what it looks like. And so to push this a tiny bit further, you can basically say, okay, let's look at, let me look at year-on-year growth by subclass, and let's look at the growth spurts and see whether we can relate these to some sort of technological events. And so I already talked about development tools and productivity, which saw this growth spurt in 2023, 2024. And so here, obviously, it's directly, you see GitHub Copilot and the advent of using the Gen AI for coding. So there's a somewhat similar story with generative marketing and asset production. But one which I found, for example, interesting, in 2019 to 2020, you see this huge growth in immersive experience systems. And what was happening in 2019 and 2020? Well, COVID. And so you see that's another one of these which is quite interesting. The two last ones are, again, I find them quite fun and interesting, is you have this big growth in the medical intervention systems in 2017, 2018, potentially related to the fact that there was the FDA's first approval of an AI diagnosis system. And for those of you who know attention is all you need, that also seems to have spurred some research into core AI and algorithm engineering. So another one which is cool, which is also what's hopefully going to happen as we go on, is, again, we look at the things that are happening right now. We are able to, like, really what are the what is happening in the AI use case world? What are firms doing with AI? And so here I'm just telling you that the highest growth subclass of 2025 we have had so far is the subclass called Talent Acquisition and Recruitment Intelligence, which is in the human resources and talent management one. And so here you can, the highest, most specific use case within that was job matching recommendation, there was quite a few of them, and then others. So let me tell you one more thing, since I'm running out of time. Another thing you can do is that these use cases are, again, they are not by sector, right? They're by domain. And so one of the interesting things you can do is actually start looking at, well, what does that look like in a specific sector? And I thought that showing you the public sector would be really quite interesting. So these are the classes ordered by their frequency across the full period. And here, maybe unsurprisingly, probably unsurprisingly, AI in defense and military systems is the highest one. But now, in the past year or so, this is the growth from 2023 to 24, the biggest growth is seen in this public sector governance and smart cities. And so just to give you now one little glimpse at what the actual use cases are when we get, like, down to the nitty-gritty, you can see things like improved digital interactions with Massachusetts government services with a chatbot, or border security and law enforcement using AI and machine learning. And so this is the type of, like, low-level granularity that we have with the use cases and which maps into the higher level of the taxonomy. So again, contribution I think we've covered, but what I want to say is, like, basically the plan is that now we start doing this on a continuous basis and start having this sort of, like, looking at what's happening. And then for the taxonomy, we want to make it deeper and more granular, because as you can see, there was quite a big gap between the use cases themselves and the taxonomy. We're also planning on adding cross-class tags for the actual methodology that is being used. We're extending it to more countries now. And obviously, as you can see, we've just started getting going with the actual analysis on this. And we're looking at, we have started doing like diffusion across industries, also using the skill profiles and the educational backgrounds information. And with that, I'm going to shut up and answer some questions.
Might even just allude to them most of the time, because people who are writing the job postings, oftentimes in HR, are not the people who are doing the jobs. So how are you doing any kind of bias correction, anything like that in your data?
No, not at all. So that is 100% true. That is 100% like a bug of this. But on the other hand, it's first of all, it's unclear to me how one would correct it, because it's a selection bias, which is essentially hard to touch. And the way we saw this, at least to start off, is to literally just have some system that tracks what we can see. And you're right that any analysis which then ends up looking at like fractions or time series is always going to have this problem with it. But our hope is that at the very least it gives us some sort of like, again, bellwether of what is happening. But you're absolutely right. If you have an idea about how to correct it, then I'm all ears. But I think except for coming up with some specific selection bias model, I think it might be complicated. Yeah.
Great presentation. Are we matching people or matching signals about people the system believes are predictive?
So here, there are no people involved at all in this. So what we're looking at is, you have a job posting. Think of the most classic job posting you can think of, like hiring Economist at Burning Glass or whatever, and then it'll list out whatever is on a job posting generally. Like it starts off with, this is what Burning Glass does. So by the way, this is just to get to the point that was mentioned before. Like this is one place where you can find an AI use case which might have not been known by somebody else. It's like if the company itself is hiring somebody that is not AI related, but is talking about the fact that they are doing something with AI, that'll also give us an AI use case. And so basically what we're doing is you take this job posting, it's entirely impersonal, right? It's just something that has been posted on the internet to find somebody, and we put it through this entire pipeline and pull out the use case itself. So that is the process here. There's nothing else. Does that make sense? Yeah.
If you don't mind, I want to ask a nerdy question about the methodology.
Mm-hmm.
So I tried to do similar things. I'm using the link-up data.
Mm-hmm.
Yeah, what I found is that actually BERT model is better than GPT in classification. So maybe it's a classification. You said that you have labeling versus classification. I got the classification part from one of BERT, but what did you do for the labeling?
So this is very interesting, and we can talk about this a bit more, because I think one of the things which was surprising to me, so I've been doing like NLP for quite a while now, and up until maybe a couple of months ago, my default would have always been BERT or modern BERT will do better than an LLM, and so like but if you fine tune it, it'll do better, right? I mean, obviously not out of the box, but that's what the fine tuning is for. It turns out, like with this now, in my attempt at classification, the LLM is doing better than the fine-tuned model, essentially. And so the reason why there's a fine-tuned model in this still is simply price, right? You can't run like millions of things through GPT. But we can talk more about this, because like I said, so one thing which made this in some sense possible is the fact that labeling through LLMs has become possible and reliable enough for this to be the case. And obviously, there's still humans in the loop, et cetera, et cetera. But yeah, happy to talk more after. Thanks.